Hello everyone. Today I am going to present one of the best part of the organic reaction, that is addition and oxidation reaction. So, today we will focus more about that carbonyl group. So carbonyl group basically aldehyde and ketones. So nucleophilic addition on carbonyl groups, how it will be, we will discuss about that. So here that carbonyl group actually polar group, that is dipole moment it has, because that electronegativity difference is there. So and different kinds of carbonyl groups having different dipole moment also is there. Based on that, that electrophilic center, that carbon having that electrophilic center, because delta positive charge already generated, so that's why nucleophile can easily attack on that center. So next slide, actually there is a just there is an example of that nucleophilic addition here, that is an carbonyl groups. Nucleophile can attack in that center and O minus is generated. So this carbon center is sp2 hybridized, that is basically planar, and after that reaction, that is form sp3, that is basically tetrahedral in structure. So that approach can be explained through orbital overlapping. Now carbonyl groups, that is basically in LUMO level, that pi star, and that incoming nucleophile is HOMO. So the HOMO and LUMO, that interaction is there, I mean that overlapping is there, and finally new sigma bond is formed. So that is transfer to sp2 carbon to transfer sp3. So now the example addition of HCN. So this is the one of best example where CN is nucleophile, can easily attack to that electrophilic center of carbon, and O minus is formed, and that O minus is collect that H plus ion and form cyanohydrine. Okay, CN and OH is formed in a carbon. So basically it is an chiral center carbon. If we further proceed for these molecules, if we treat it with H2O, that then cyano group transferred to in acid group. Okay, so next the similar reaction, addition of sodium bisulfite. That sodium bisulfite is mechanism is a similar way, where bisulfite react with water and sulfite is formed. That sulfide ion actually interact with that electrophilic center and finally form these molecules. Okay, so this is another example of additional reactions. So next one is very important reaction, that is addition of Grignard reagent, RMGX. Okay, R may be any kind of alkyl groups, magnesium and halide groups. X is a halide. So this is first one is addition with formaldehyde, that HCHO. So where that negative part, that is R, here actually CH3 CH2 ethyl group, that actually interact with that carbonyl carbon atom, and finally it will form that a alcohol group. After workup, that is abstract that protons, one propanol is formed, 1 degree alcohol. Okay, so next one is aldehyde. So aldehyde also the similar reaction, and after that workup, that is 2 degree alcohol formed. Okay, so now the next one is addition with ketone. So carbonyl group having both side carbon atoms. Here also we can observe that OH with 3 carbon groups is there, and ultimately it will be formed 3 degree alcohol. So based on that, primary, secondary and tertiary, 3 type alcohol we can obtain by these Grignard reagent reactions. Okay, one step process. So now there is a just question: what should be the correct order, reaction order, reactivity order? First one is aldehyde, acetaldehyde, then formaldehyde, and there is a one side is benzene ring, one side is methyl. So can you tell me what should be the reactivity order for this using Grignard reagent? So here actually the reason that the second one, I mean that formaldehyde will be the highest, I mean that fast reaction as compared to 1, as compared to 3. Why? What is the reason behind that? Reason is that electrophilic center is different because the generated electrophilic center delta positive charge cannot reduced by any kind of other groups, where in case of that aldehyde, that is one methyl group, due to plus I effect, it will be reduced delta positive charge, and here also resonance also involved for this reduce that delta positive charge. So that's why chronologically ordered 2, 1 and 3. These are the reactivity order. Okay. So now the similar way, addition of ammonia. So ammonia also interact with that carbonyl groups and form imine, and this is the another examples form of urotropin. This is sometimes used for making explosive, and also it is used for antiseptic for urinary infection. Okay, so now the others reaction derivative of ammonia groups, that is 1 degree amines and hydroxylamine, corresponding product is formed imine, oxime, if it is OIs is there, then hydrazone, semicarbazole, and etc. etc. The reaction process is same. Okay. Now the next part of the addition reaction, that is electrophilic addition reaction. Okay. So alkene group, we are selecting alkene, different alkene. So alkene basically pi cloud is there. So that means it can easily attack with that your electrophile. So here two types alkene is there. One is symmetric alkene, another is asymmetric alkene. So this depending of attacking electrophile, actually addition reaction is two types: electrophilic addition of HBr and electrophilic addition of bromine Br2. So first is symmetric addition. HBr, when addition with the symmetric alkene, here two groups are, both groups are same, here both groups are same, so there is no problem. That means 100% product you can get, maximum product, major product you can get, this one or this one. But if is unsymmetric alkene is there, then it will be question which product will be major and which product will be minor. On that basis, scientist Marconi generated rules. That rules state that when a protic acid is added to an unsymmetrical alkene, the acidic hydrogen is added to the carbon atom having greater number of hydrogen atom, and the halide or anion is added to the carbon atom having lesser number of hydrogen atom. So let's example for Markovnikov's reaction. Here actually unsymmetric alkene we have chosen. First alkene pi clouds abstract a proton. So then there is a two possible way. Carbocation generate from here either or here. Okay. So then Beer minus actually having two ways, either can attack in that side or in that side, and corresponding product will be formed. One is 2-bromo-propane, like that, different substitution, 2 position and 1 position. Okay, so now which product will be the major and minor? Actually that depends on the stability of carbocation. Here actually stability, this carbon is tertiary carbon, but here this is secondary carbon. As we know, secondary, tertiary and primary, that carbocation stability order, tertiary will be more stable than secondary, then tertiary. The reason is that the tertiary having 3 methyl group is there, 3 plus effect, 3 plus effect, inductive effect. So it will more stabilize the carbocation as compared to secondary and tertiary. Another reason is there, it is a hyperconjugation. The more of alpha hydrogen, more alpha hydrogen, more stabilized that carbocation. Okay, so here more carbocation stabilized product will give the major. Okay, so this is the another example, that is basically propene, 1 propene, and similar way that 2-bromo propane is formed. Okay, so now the next question, if it is its opposite, I mean if we added some peroxide effect in addition to the HBr in an unsymmetrical alkene in presence of peroxide which induced a radical reaction pathway. This is very important, that reaction pathway is radical. Okay, so the product will be the reverse, opposite, the major product will be the opposite of Markovnikov rules. Okay, this is also known as Kharatz effect. But remember here, radical addition do not proceed for HCl and HI. It is only used for HBr, because in case of HCl, that bond breaking process is that bond breaking energy is huge, so it is not proceed for the next step. So in another case for HI is bond breaking process is very easy, labile bond. But after the formation of iodine radical, that radical simultaneously form I2, iodine is formed. So that's why the best chemical for that reaction is HBr. So here actually that peroxide homolytic cleavage, and after that form that radical species is formed, and that radical species abstract that protons and form free bromine radical. This step is initiation. That bromine radical actually can attack from this side or can attack from this side. So two possible ways is there. Radical can generate here or can generate here. But here also the same thinking, which radical will be the more stable. Here also we will conclude that secondary radical or tertiary radical will be more stabilized as compared to primary radical. So here the Br dot use that type of product that is more stabilized. So as another simplistic example, here also I have chosen that propene and HBr with peroxide, that 1 bromopropane will be the major product and 2 bromopropane will be the minor product. That is just reverse for only Markovnikov reactions. Okay. So next is electrophilic addition for bromine Br2, that is vicinal dibromide product is formed. That this reaction is very important. Why? Because you can find it out that that unknown compound having unsaturated or not. If we dropwise addition of bromine to an unknown solution, unsaturated solution, then bromine reddish color will be disappear. So what is the mechanism? Mechanism is that this is triangle type of structure is formed, bromine plus, and that leaving Br minus attack either this side or this sides, and product will be trans type of product is formed. If it is chiral center is there, otherwise we will call it is an vicinal product. Okay, so now we can use for chloride also, vicinal dichloride product also is formed. Okay, so next reaction is oxidation reaction. Okay, so oxidation reaction here, first alkene react with any kind of peroxide. So that peroxide actually form epoxide, oxidane. Epoxide is formed, triangle shaped. So this is the mechanism. Peroxide is react with that with a double bond and form a transition state structure, and after that epoxide is formed. Okay, so this reaction is very fast reaction. So if you select first cis alkene, then cis type of epoxide is formed. If we select that trans alkene also formed. That means we cannot change that stereochemistry. Stereochemistry is written, I mean that remains same after that reaction. Okay, so this is the one of the best example for oxidation with the help of our metachloroparbenzoic acid. Metachloroparbenzoic acid, this is a paracid also. Okay, this is this MCPBA we will use for the production of epoxide. Okay, so now next one is that the example cyclohexene. So, methyl cyclohexene actually the oxidation by using MCPBA, metachloroperbenzoic acid. What should be the product? Product is that epoxide form. Okay, so if we extend it, the oxidation part of extend it, if we add water, so that water actually form the product diol. OH diol is formed, vicinal diol also formed. But remember this, if it is your stereochemistry carbon, a stereocarbon is there, chiral center is there, then it will be trans type of product is formed. Okay, because opposite side that nucleophile attack, that open up that opposite side, that's why it will be trans product is formed. So after that epoxidation, so many application is there, medicinal potentiality use as in biochemical probes, different kinds of reaction are there, so many application are there. Okay, so now the next one, that for alkene we are using cold alkaline KMnO4. So that time we will also getting that OH, I mean vicinal diol formed. But remember, this is a sine addition or sine addition, same side OH can form. This is KMnO4 minus, that is reaction is a cyclic member is formed, transition state, and finally it will be formed that vicinal OH group is there. Okay, so this is the oxidation part. Okay, so now the last part of oxidation is ozonolysis. Okay, so ozonolysis, ozone cleave that carbon-carbon double bonds to form an intermediate called ozonide. Okay, by 1,3 dipolar cycloadditions. They can be isolated and decomposed by suitable reagent to give aldehyde and ketones as the products. Okay, so these are the this is the example of double bonds, I mean alkene and O3. They form ozonide structure, free oxygen inserted here, and after the final step, that dimethyl sulfide or zinc dust water, mild reducing agent, and it will be formed that carbonyl groups, ketone and aldehyde is formed. So what is the mechanism? Mechanism is that there is a zwitter ion is formed, that positive and negative charge also is formed in O3. So that will be attacked and cyclic member product is formed, that is molozonide, and after that fragment of initial ozonide is formed, and that initial ozonide can reverse attack is there and form ozonide, and which is after uh, reduced, that is form actually C double bond O, using that dimethyl sulfide or zinc dust water. Okay, so these are the different examples using ethane, that will be the same type of product, 2 moles same type product, formaldehyde also forms, different substituted product is formed. Okay, so these are the different examples. So now the last one and best example, benzene. If we treat it with benzene with ozone required 3 moles because it has 3 double bonds. So ozonide structure will be like that. Benzene triazonide structure is formed, and if it is using that zinc dust and water, it will be cleaved like that. This one, this one, this one, this one. this one and this one. So the 3 moles of glyoxal, 3 moles of glyoxal is formed after that ozonolysis reaction of benzene. And these are the another different application oriented examples where we can get the product of aldehyde and ketone based product. So